Hi, my name is Bawa John Agmada. I'm doing a presentation on assessment of factory design requirements of pharmaceutical factory buildings in southwest Nigeria. In production, the pharmaceutical factory started experiencing expansion in production around the world between the 1800s and 1910s. There were some rebuildings that were done during the interwar periods, but they experienced much more rapid and international growth after the Second World War. In 1990s, manufacturing was more specialized and complex and spanned across many countries of the world. Pharmaceutical factory buildings are known to maintain serene environment, especially in the production areas. Pharmaceutical factories usually have dedicated facilities for the production of particular pharmaceutical products or biological operations aimed at minimizing the risk of health hazard due to cross-contamination. Variety of chemicals are used for the production of a wide range of drugs for human consumption. Therefore, there is the uncertainty and unpredictability of the quality of the indoor environmental air of these factories, and they are suspected to be the cause of sick building syndrome, thermal, visual, and acoustic discomforts, which cause psychological fear and physical complaints. The findings from this research will help the operators and stakeholders of pharmaceutical factory buildings improve in their operations. Pharmaceutical factories in Nigeria have gone through thick and thin, and expansion has been on the steady increase despite denting challenges around their development. As a way of literature review, pharmaceutical factories are not usually designed with windows. Even the ones that um, have only but fixed windows. But we know that these windows help grant access to nature and natural lighting, and to an extent reduce the cost of production, and increases well-being and reduce stress level. Researchers have also dived into two broad areas, which include the building designs that buttress and improve the indoor air quality by increasing ventilation rates, which will in turn reduce air pollution. Pharmaceutical factory buildings maintain active control and restriction of the inflow of outdoor climatic elements into the indoor environment of the production areas, so that the chemicals, the process, and the drugs being produced are void of contamination. There have been global standards for these parameters that have been found usable for this research. Lagos and Ogun states have been chosen as the study area largely because they contain the highest number of pharmaceutical factory buildings in Nigeria. Out of the 126 registered, Lagos and Ogun State have 57 and 16 respectively. Handheld instruments were utilized for the measurement uh, of this research. Some of these handheld instruments include multifunctional air quality detectors, sound level meters, uh, distance meters, digital anemometer, and a couple of others. For the sampling technique, 14 pharmaceutical factories were chosen through purposive sampling, inclusive and exclusive criteria, and non-response rate. The method of data collection included measurement of all the parameters in about 15 points in all the 14 pharmaceutical factory buildings within an interval of 3 to 5 minutes, and this was carried out when drugs were being produced, machines were working, and the workers fully occupying the buildings. Results and discussion. The data was analyzed using descriptive analysis after comparing the outcome of the data collected with the globally recommended standards for factory design requirements. The assessment of this factory requirement compliance of pharmaceutical factory building was carried out by assessing different cases and comparing the same through the ideal scenario. This was aided by undertaking a workers' productivity reliability test and testing other parameters that concern factory requirements, as will be seen on the tables below. The tables will show the result of reliability test, highlighting the mean and standard deviation of the responses of the factory workers. Factors that determine workers' productivity were also measured to determine the factory to determine how the factory design contributed to the productivity of the workers. These are some of the tables showing the number of the units, showing the reliability test using the Combat Alpha that showed about 75% reliability, which was good enough for the analysis to continue. And then this is the table containing the analysis of the standard, of the mean and the standard deviation of the questions that arose. Questions such as the size of the production area, whether it was enough or big enough for moving around, whether the production area was enough to accommodate the machine and the workers, whether the floor, the walls, the ceiling finishes were suitable, the chairs, tables, and the machines were movable during sanitation. This is the table showing the scale mean, scale variance, total correlation, and the Combat Alpha reliability test of each of the questions. The requirement compliance of pharmaceutical factory buildings to the size of the space for the production for free and easy movement recorded about 80% compliance. The headroom of the production area, whether it was suitable, recorded about 92%. The safety of the floor, the ceiling finish, recorded between 90 to 93%. The comfort of the seats, the furniture, the table that was used, between 79 to 91%. The ease of movement of the production machine during washing and cleaning, about 60%. And then occurrence of mixes of chemicals recorded about 19%. 8 out of the 14 pharmaceutical factory buildings that were observed were below the acceptable standard requirement in terms of the headroom of the production area, while 4 pharmaceutical factory buildings had inadequate room sizes per equipment and workers' recommendation. On the material finish of the floor, walls, and ceiling, 4 pharmaceutical factory buildings did not meet with the average standard. About 65% of the pharmaceutical factory buildings were within the compliance range of the global best practices. Meanwhile, on the indoor air quality, with the least noticeable difference with the set out standard was the relative humidity, which had only about 6% variance with the standard, which was followed by air velocity, which had about 11%, and then temperature about 12%. This study recommends more research in indoor air quality in pharmaceutical factory buildings in Nigeria to generate the most appropriate benchmark for the Nigerian setting. Thank you for your time, and God bless.